Now that we've learned about simplifying, we're going to go on to multiplying and dividing using radical symbols. So let's go ahead and open the flat for multiplication. And we see that we have the product property. Well, what this says is that we can take the square root of AB and turn it into the square root of A times the square root of B. And how this really helps us with simplifying is that we can factor the radicand, which is the part inside the radical symbol. We can factor the radicand into the product of a perfect square. And another number. So if you remember down the bottom of your paper when we were doing the square root of 24, we factored it into 4 and 6 because 4 was the perfect square and 6 was not. That was our other number. So that's how that can help us simplify radical expressions. So let's look at example 3. Example 3 has the square root of 9 times the square root of 9. Well, we can put these back together and say that this is the square root of 9 times 9, all under one radical symbol, equals the square root of 81, and the square root of 81 is 9. Take a look at example 3. So now we have 3 times the square root of g times the square root of 2g cubed. Well, we can go ahead and put this all together. Anything that's on the outside is going to stay on the outside, and anything on the inside will now be grouped under one big radical symbol. So I've got a 3 on the outside, and I'm going to keep that 3 outside, and then I'm going to put inside this g times 2g cubed. I can rewrite that as 3 times the square root of 2g to the 4th power, and g to the 4th power is a perfect square. G squared times g squared gives me g to the 4th power. So I can simplify this to be 3g squared square root 2. And that's my final answer. Number 5, 2 times the square root of mn squared times the square root of 5m squared. Again, I leave what's already on the outside outside. So I'll have 2 times the square root of m n squared times 5m squared. I can combine like terms to make this 2 times the square root of 5m cubed n squared. Well, we know that we would have to break down that m cubed, so it might have been easier to look at it like this. I don't know the square root of 5, so that's going to stay on the inside. I don't know the square root of just m, so that also is going to stay on the inside. I do know the square root of n squared, it's just n, and the square root of m squared is m. So on the outside I'm going to have 2mn times the square root of 5m. Let's take a look at divide now. So we go ahead and open this back up again. Now we see we've got the quotient property. This is very similar to what we had for the product property. And we can go ahead and separate this fraction up. We can rewrite the square root of a over b as the square root of a over the square root of b. So again, this will help us to simplify radical expressions because we can simplify each square root separately. So let's take a look at number 6. We have the square root of 5 over the square root of 4, or square root of 5 over 49. We can rewrite this as the square root of 5 over the square root of 49. I don't know the square root of 5, so that's going to stay inside. I do know the square root of 49 though. It's 7. And that's my simplified answer. The next one is the square root of 11 over d to the 4th power. Well, I can once again split this up. Square root of 11 over the square root of d to the 4th power. I do not know the square root of 11, so it's going to stay inside. So d to the 4th power. If these exponents are still kind of confusing you with these radicals, we can go ahead and try to make it look like the factor tree like we did earlier. I can break this up into the square root of d, square root of d, times the square root of d, times the square root of d. I have 4 d's. So again, I can go ahead and circle my pairs. I've got nothing left over. So pairs go out. So I have a pair of d's there and a pair of d's there. So on the bottom here, I'm going to have one set of d and another set of d. Well, when I combine those back together, I get that the square root of 11 is d squared. Again, d squared times d squared equals d to the 4th power. And that is our final answer. Well, that's it for these notes. I'll see you in class tomorrow.